Are you ready to study along with YouTuber Melissa Lucy as I teach her and you quantum numbers? Now, there are 4 different types that you're going to have memorized and have to, be able to figure out based on, I'd even say like kind of based on the format of the electron configuration, which we'll cover. But overall, what quantum numbers do is that they describe the overall orbital of an atom. So specifically, the first 3 quantum numbers are going to tell us about like more descriptions or tell us more about our orbitals versus the last one talks about the electron. So for this first one, I know we saw this already with like N with electron configuration where you had like 1s, 2s, and so on. And we were talking about the energy of the orbital. So N really just describes the size or the energy of the orbital. And we know the higher up or the higher number it is, the more energy it has. And then versus the next one, which is L, or angular momentum, that just means like what shape is it? Is it S, is it P, is it D, or F? And remember those shapes that we were looking at before, like S had more of a sphere shape, right? And then P had more of that like, kind of like a balloon, where it looks something like that, right? Kind of like those like balloon animals, it kind of looks something like that. And C. And then D and F were a little bit more, I'd say, more complex. You're not expected to know like the shapes of, I'd say, even F or D, but that's basically just describing the shape for the next one. Now, it's going to be really important to understand, actually have this memorized. So you're not going to get this on the test. Definitely have this little table here memorized completely. So if L is equal to 0, it's going to be S. If L is equal to 1, that's going to give us P. L is equal to 2, D, L is equal to 3, F. So instead of it being like 1 through 4, it starts 1 less. So it starts from 0 and then goes to 3. And then now for the next one, that's basically just going to tell us the orientation of the orbital. So you can think of it kind of like with P, how this is centered on the x-axis or y or z-axis. And it's basically telling us where is it. So how is it like oriented? So this is going to be really important to know because like you have to know the L to know the M sub L or the next quantum number. So M sub L is basically just the negative L to the positive L, and I'll explain what this means. So if L is equal to 1, then that means the M sub L is equal to negative 1, the next number, 0, to positive 1. Like if this was 2. If L is equal to 2, then M sub L is equal to negative 2. Then all the numbers in between, all the way to positive 2. So next one is negative 1, 0, positive 1, and then positive 2. Does that make sense?
Actually, no, I'm confused. I'm sorry.
Okay, no problem. What doesn't make sense?
So I get that L represents these different things, but what is the M sub L?
The orientation of the orbital. So like for the p orbital, there are different, like there's 3 of them, or I'd say actually like this is px because it's centered on the x-axis. This is py because it's on the y-axis. And then this is pz because it's on the z-axis. So it's basically just like how is it oriented in space?
Okay.
Does that make sense?
Yes. So are they gonna like ask us to write out that like -2, -1?
Yes, they are. They're going to ask you like to actually write out all the possible quantum numbers for an atom or for a specific atom. So we'll definitely have plenty of practice of this, but just knowing that it's always that from that negative L value all the way, like all the numbers in between, to the positive L value. So like when L was equal to 1, I start off with the negative value, so -1, the number in between 0, and then the last one is just the positive value.
I get it now. The first time you said it, I like didn't understand like where that was coming from. But okay, that makes sense. So that's why we have to memorize the initials so that we can do it. Okay, got it.
Yes, perfect. And then the last thing, so everything we just talked about the orbital. The M sub S, or the spin quantum number, talks about the spin of the electron. So remember, that's kind of like what we saw before when we were doing orbital diagrams with our electrons, showing the spin like, oh, this is going up. Well, that's a positive. That's a positive 1/2. And then if this is going down, that's a negative 1/2. And then if we were to have, like, let's say that little orbital diagram that we saw before, let's say this is 1s2, well, we saw that this filled that orbital. And then I know that, okay, well, this is both plus or minus 1/2, since I have both the, the positive one and the negative one pointing down. Cool. Questions here so far?
No, it makes sense. Yeah, I'm glad because I was doing these I've already covered like in the homework, but I did not understand it. Like I didn't get it. So now I get it.
Got it. Okay, nice. The next thing I'm going to look at right now, I'd say this question isn't as common. The next ones that we will go after this one over, like those are going to be the most common, but just in case they throw it. So for this is saying, what is the spin quantum number for sulfur? So remember the spin quantum number was the one we just saw before, which was that m sub s, and that could either be plus or minus 1/2. Now, how you could figure that out, like how do I know if it's going to be a positive 1/2 or a negative 1/2? That's going to be based on our electron configuration of the atom that they give us, which in this case is sulfur. So let's kind of go back to what we learned before and write out what the electron configuration is for sulfur. You could just do the abbreviated or condensed electron configuration. Do you have your periodic table on you? Okay.
By the way, side note, I took all of your things and I put them in clear things, and I need to get a folder with like things in it, but I'm gonna put it in there, and I have all of them, so it's like so cool. And then I put in the front like the periodic table.
Very nice. It looks really nice.
Thanks. I'm like so happy about it. Okay. Anyway, so sulfur. Here we go. Let me figure out where that is on here. Okay. So it's going to be neon in the brackets.
Okay. Mm-hmm.
And then 3s2, 3p4.
Correct. Perfect. So now if I were to draw the orbital diagram of this, so I'll do that now. So we know we'll represent just, let me make that nicer. Our first one, which is 3s2. And the next one, or I could even just put 3s. We need 3 since this is going to be 3p. And then I'll do what we did before with our orbital diagram. So there's 2 electrons here. And then now I'm going to look at those 4, obeying Hund's rule. So this is 1, 2, 3, come back around, and 4. So this question is only looking at the last electron. So is it, pointing up? Is it pointing down? So our last electron was this. And since that's pointing down, our m sub s is actually a negative 1/2.
Okay, that makes sense.
Cool. That's it. That's how you would answer these types of questions.
Cool. That's not bad at all.
Awesome. Okay, moving on. So like we said before, the first 3 quantum numbers, so like n, l, and m sub l, describe what our orbital is essentially going to look like, the energy level, and so on. So I wanted to explain a little bit more where this comes from and how everything comes together. So starting off with, let's say, something that is in that like 1s category. So in that first row on our periodic table, we know that, well, that 1 is actually going to represent our n, or the energy of our orbital. And then the L, that comes from our little chart that we saw before, which is going to be the shape of the orbital. So L is going to, since it's equal to 0, that means it's S. So that's where I got, okay, I know that's S. And then the last thing again was m sub L is equal to that, that negative L to positive L. And since L is only 0, we can't have a negative, there's no negative 0, it's just 0. That's why m sub L is just 0. Does this make sense?
Yes, I'm just like trying to figure out how that's going to apply to a question. You know what I mean?
So
like, what are they going to ask me from this?
So you could actually be asked, like you can just be given 1s and they'll ask you write all the possible quantum numbers. And then you'd have to know, well, okay, this 1 tells me the n value, which is 1. This s represents the L value here. So I know L is equal to 0.
Oh, I see.
And then from there, since I know M sub L is like that negative L to positive L, then okay, M sub L is just 0.
So do you think I need to know which thing represents, like, which one's the shape, which one's the spin or whatever?
Yes.
Because they might say that.
I would say exactly. They might ask it in a question and they won't say, oh, what's M sub L? They might say, oh, what's the orbital orientation? And if you don't know that, then, that doesn't help.
Okay, got it.
And then same goes for the next part. So what we could actually be given in this case was we could just be given, well, N is equal to 2, and then L is equal to 0, and M sub L is equal to 0. And we'd have to figure out what the orbital is essentially. So if they were to ask that, then we know, well, 2 is going to represent the coefficient in front. And then I know L is basically telling me exactly what orbital shape it is. So S. And then I know that's where this came from. So 2S, done. I don't necessarily need the M sub L in that case. But that's another way. So it could, either way, doesn't matter. You could figure it out. I'm going to kind of jump to this end here. So same thing for this part. I know that if I were to be given to P, the N is going to be 2. And then P, we know that this would have been L is equal to 1. Our M sub L is our negative L to positive L. So -1, 0, and 1. Next one here. If I were to have 3S, I know that my N is this value in front, so 3. If it's S, that's going to give me 0 for my L. And then M sub L is 0. And you're going to keep seeing this pattern. Okay, 3P, well, the N I'd say is probably the easiest one to identify. And then where most students go wrong is just forgetting this table. Okay, right? So this, the fact I know is it's sometimes something extra that you have to memorize and you have more than enough to memorize. I remember. So that P, just knowing, okay, well, it starts off from L equals 0, L equals 1 is the next one, and P is the next higher orbital energy, I guess I'd say, higher up in energy. So that would be P. And we'd go from there. So any questions so far? I want to do a bunch of examples.
No, it makes sense. I'm good. Thank you.
For this one, this is a potential question that they could give you saying, list all the possible quantum numbers for the following. So I would start off with A, and I'll see, well, if this is 4S, this first part is telling me what the N value is. So N is equal to 4. And then next, the S tells me what the L value is. So remember that table, the first one, L equals 0, is our S orbital. So that would have been just 0. M sub L then would have been basically just negative L to positive L, which in this case, the only thing we could have is 0. So that's what it would be. And the last one, M sub S, there's nothing, there's no other information. This doesn't tell me that it's 4S1 or 4S2. It just says 4S. So I'm just going to say it's plus or minus 1/2. However, if this were to have been 4S1, remember it would have looked something like this, where it's just one electron there. So that would have been pointing up. So that would have been a positive 1/2. But if this was 4S2, then I would have 2 electrons, and I'm just focused on that last electron, and it's pointing down.
Okay.
But because they don't tell me, I'm just going to say plus or minus 1/2. And then for part B, a little bit different. So now we have 4F. Again, this 4 is going to represent our N. And then our L, well, this is, I know I'm going to figure out the L from the whatever value I have here, whatever orbital I have here. So I have F. Remember the table looks like this, where there's S, then there's P, that's 1. D is next, which is 2. And then F is 3. So I know L is going to equal 3. I'll move on to the next quantum number, M sub L. So this is a negative L to positive L. So I'll start off with the negative L value, which is -3. Then continue with all the numbers in between. So -2, -1, 0, 1, and then 2, and then to +3. So all of those values are possible. And then the last thing is just that spin of the electron, or m sub s. Since we don't know, I'm just going to say plus or minus 1/2, since they didn't specify how many electrons are in there. Makes sense.
Yes.
Cool. Okay. This next one. All right. So this question I have seen on most exams. Definitely know this. This one is, it may seem tricky at first, but I'll explain it. I'll help you understand it a bit better. So this basically is telling us which set of quantum numbers isn't possible. And we're going to go through every single one, and I'll tell you why it either is possible or isn't possible. So starting with the first one, just looking at A, I want you to, and actually I'll write out what we have here for that table. I know you don't have it memorized just yet, since I literally just taught it a second ago. All right. So just looking at A, what does this represent? And by that I mean, is it 1s? Is it 2d? Or 2p? What is it?
Oh, it's 2s.
Try that again. So you're right with the
2. 2p, because it's a 1.
Yes.
Okay. Wow, I didn't know you could go backwards with this. Okay. 2p.
And then that's all we would know, because this doesn't tell us, what anything else. We don't know how many electrons there are. It just tells us, okay, this is 2p. Well, I know that looking on my periodic table, is 2p possible? Well, yes, it is. It is possible to have, 2p for an electron configuration. So, okay, that's fine. The next thing I'm going to look at is I'm going to see, well, does the m sub l make sense that it's -1? Is it allowed to be -1? And the answer is yes. And it's because L is equal to 1, m sub L is -L to positive L. And we're literally just given the -L. That's fine. This didn't ask us for all the possible quantum numbers. It's just saying, is this specific set correct? So this one, or isn't possible, or whatnot. But this one specifically is correct. It works. It's valid. Does that make sense?
Yes.
Okay. So then looking at B, what would this be? So once again, this one was 2p. What would this be?
So this one would be 3d.
Good. Is that allowed? Looking at our periodic table, can we have 3D?
Yes.
Does that exist? Yes, it does. So check. Next thing we look at is just the m sub L. So can m sub L be 0?
Yes.
Yes. Good.
Because it would be -2, -1, 0, 1, 2.
Yep. Exactly. All of these. Exactly. Perfect. Okay, so that one's fine. Looking at C, what would we have?
We would have 3f.
Is that possible?
(3f)
Exactly. So that reaction is perfect, because we can't have that. Looking at, I know. So looking at the periodic table, what's the lowest F that we have, in the F block? What's the lowest coefficient or n value?
Well, it would technically be 6, right?
Try it again. Remember, for F, it's always 2 less than the row that it's in. And the F is all the way at the bottom. It's the one detached from the periodic table, or the main groups.
So it's not 6?
It would be 4. So if I were to...
Oh, well, the reason I said 6 is because I was bringing it back up to here, where you take this whole section.
Got it. Okay, no. So we think of it like we would with the electron configuration.
So we slide it up to where it would be, and then we take 2 from that. So it would have been 6, so we take 2 from that, and then 4, make it 4?
Yes. Yes.
Okay.
Yes.
Cool. I forgot that one.
So that's why this doesn't exist. It can't work, because the lowest n value that we could have for F is 4. So only 4F and above, really it's only 4F and 5F exist, not 3F. So that's why this is wrong. So for D, I mean, we're still going to do D just to, really make sure. But what would that be?
It would be 4F.
And that's it. So yeah, 4F, we just saw that that's correct. That's why it works. We know that the M sub L can be 0 because what are all the possible M sub L values that we could get for this one?
-3, -2, -1, 0, 1, 2, 3.
Exactly. I know we just covered a lot of information, and sometimes this tends to be a little bit complicated, but I just want to tell you that it's okay if it's not clicking right now. If you have to rewatch the video, take some notes, that's totally fine. All that matters is that you're trying and that you're working towards this goal. And honestly, I know you can do this.